Hi, folks. Today I thought I'd introduce you to Scratch and kind of get you going on it. I could go through every little, feature and command in Scratch, but I've always found that the best way to learn this software is to kind of play around with it. Play around with dragging your programming commands in and seeing what, looping does with the forever loops and the loop until, and working on creating variables, working on making decision-making structures. It's kind of fun just to play around with. But I figured I'd do one example with you, which would both demonstrate a little bit about Scratch and also demonstrate how flowcharting can help us build a program that otherwise we may have stumbled through. So I'm going to use the flowcharting example that I created in the other tutorial video on flowcharting, and we're going to see if we can duplicate this program in Scratch, just kind of on the fly here. My Scratch might look a little different from yours. I'm going to use the desktop version, which you can download if you wish. See if I can find it here. There it is. Okay, so here is Scratch the Cat, and you can grab him, you can move him around. What we're going to do today is we're going to try to get Scratch the Cat to give us some feedback and go through that, the problem that we have on the flowchart, and ultimately tell us what the sum of the first 50 natural numbers are. Okay, so just a bit about Scratch the Cat first. This is actually the output window, so example of computer output. So whatever we do in the programming area, which is on this side of the screen, should be reflected on this side. The screen, one thing you should know with regard to measurement of the screen is it's a little different from normal measurements. It uses the Cartesian coordinate system, which is just the XY chart that you've seen in math before, probably several times. One thing you should know, though, is that the X value and the Y value are 0 at the middle of the screen. So any X value that's negative, X being on the horizontal, any X value negative is going to be to the left of them, and every X value to the positive is going to be to the right. Positive Y's are up, negative Y's are down. So that's just a good little navigation trip for you, because if you tell Scratch the Cat to be at a certain place, you have to know the X and Y coordinates in order to get them there. All right, so for this program, I will just flick back over to it so you can see what we're working with here. So this is the flowchart we created. All right, I'm going to set us up in Scratch so that we can just kind of get the program going. So the first thing you always do in Scratch is you need to have some sort of event to get the program going. And there's lots of different ways to do it, but I usually just start with when the green flag is clicked. So the green flag is up here, and it's basically just start program. So when the green flag is clicked, the program knows that it's going to be started. And don't forget, that's an example of input, right? We're clicking on the start button. That's us giving the computer information. And ultimately, hopefully, we get some good output from Scratch the Cat. So we're going to start with this control block when that is clicked. I'm gonna put in a command right away that puts Scratch in the middle of the screen. So just in case we accidentally dragged him off the screen or something like that, we can start every program knowing that he is where he needs to be. So what we are going to do is it is in motion. Okay, so what we're going to do here is we're going to drag in the GoToXY, and it just clicks in. It's just kind of like Lego blocks, right? So at the very beginning of the program, we're going to have Scratch the Cat go to 0x and 0y. So no matter where he is on the screen, he'll go back to the beginning. So if I accidentally drag him down there, if I go back and start my program, he starts back in the middle. So that should make it easier for us. Actually, he's going to have a little speech bubble, so maybe I might put him a little lower. Maybe I'll put him at negative 100. And negative 100, just to give him space for yeah, that's perfect. Just to give him space so that we got a speech bubble here so we can see what's going on. All right, let's flick back to the program. So we've taken care of the start module. Now we're going to go down and we need two variables. We need a variable called sum and we need a variable called n. So if we go back into Scratch, you'll notice that there's a little orange button here for variables, and we can create a variable just by filling in the make a variable. So what's our new variable name? Well, we're going to have one that's called n. Okay, and we can do it for all sprites. It doesn't matter. We're only going to have one sprite. By the way, the sprite is just a character. It's just a picture. So we've got a variable named n that we created, and then let's make another variable called sum, just like we did in the flowchart. So we've got sum. Then we're going to set our variables to 0. So what we're going to do here is we're going to bring in 2, set my variable to 0, and we have to change my variable to the ones that we created, which is n and sum. Okay, so when we start the program, Scratch glides down into the lower left. We create 2 variables. They're both set to 0 right away. Okay, so that takes care of sum equals 0, n equals 0. Now we've got a process where it gets a bit more complicated, right? We have to do some math here, and then we have to make a decision down here. So let's take a look at, first off, the decision making that we have to do. Because you'll notice that when this thing loops, it loops up to before where we start doing math. So we got to think about this. We need to loop this, okay? We need to loop this in a way that when we get down to this point and make our decision, that it comes back up and around based on the value of 50. So if we look back at our Scratch, we're going to go to our events, which is where all of our, we're going to go to control, which is where all of our looping and decision-making processes. Looping is often called iteration, and decision-making stuff is typically called conditionals. So you might find me using either one of those terms for them. All right, so this would be a forever loop, but we don't want to loop it forever. We only want to loop it until n equals 50. So what we're going to use is an if and an else block. Okay, and there's multiple ways of doing this. You know, if you were playing around with it before and I just gave this to you, you could come up with 50 different ways to create this program, and they might all work, and that's great. I'm just going to do it my way, and I always try to make it as elegant and simple and efficient as possible. So what we're going to do is we're going to take this if loop and we're just going to put it up there for now. So we set all of our initial start stuff up here, and then it's going to hit. We can't attach that yet. Then it's going to eventually hit the decision-making structure. So we're going to need some math because we know we have to add stuff to our math. So that's in operators. And you notice in operators, you've got all sort of the computer math, addition, subtraction, division, multiplication, all that stuff, greater thans, equal than. So the first thing we have to do in this program is we have to take n and we have to add 1 to it, right? So what we're going to do is we're going to drag this little block out, and then we're going to drag our variable n into one side, and then we know eventually we're going to have to add 1 to n. Okay? So that takes care of the n plus 1, but what about the sum? Well, for the sum, okay, what are we always doing with the sum? We're taking our sum and we are adding n to it. Okay, so we need actually on the exact same block, except this time we're going to drag our variable sum into this side, and instead of putting a 1 over here because the value of n is going to change, we have to put n in there. Okay? So if I go back to my program, we took care of the n equals n plus 1 just by adding 1 to n, and we took care of the sum equals sum plus n by doing the sum plus n part. All right? Okay, so here we go. Let's just think about the best way to do this here. Do I need an event? Do I need a control? I need to augment those values once for sure before we start. So, I need to put those in a set my variable to, okay, there we go, set my variable, so it's going to be set n to, and then you can drag this little thing up in there, set n to n plus 1, and I'm going to need one more actually, I'm going to need this because I need to set, your loop's always going to run once, that's why we can do this outside of the loop and outside of the decision, because we know it needs to run once. So we're going to set our sum to equal sum plus n. All right. One thing to note is that this is going to display 1 as our first number instead of 0. I mean, we could change it so that it started counting it, 0, 1, 2, 3, 4. N starts at 0 up here, but it doesn't display it. If we really want to display the 0, we can take care of that later. So we've set our variables and we've kind of set up the math so that our variables will change. Now we need to put in our decision-making structure. So once we've done this once, maybe we'll get Scratch the Cat to tell us what the variables are at any given point. Okay, so let's go into looks, and we'll have Scratch the Cat say. Okay, we're going to have Scratch the Cat say, and I'm just going to put it for 0.5 seconds because I don't want this program to run forever. Two things. I'm going to get Scratch to say the value of n, and I'm going to get Scratch to say the value of sum. Okay, so I'm going to say, okay, so say n for a couple seconds. By the way, you can also duplicate all your blocks just by right-clicking on it, and I'll get Scratch to say the sum for 0.5 seconds. I'm just going to run it and make sure everything's working properly. So he goes down to the beginning and he says 1, 1. Okay, so that was the first one. Maybe I'll just make this 1 second. So the first one is the n, and the second speech bubble is for the sum. So let's think about our loop now. So now we got to start checking things. So basically we did our output and somewhere in here parallel to this process we just displayed the answer. Okay, so far we're going to keep a running count. We could have Scratch do the whole series of math and just print out the answer, but I want us to see what's happening every time he loops through it. All right, so we've taken care of that, and now we're down to a really important part. Now we're down to a conditional. We have to make a decision, and conditionals are always mutually exclusive or Boolean. That means they have to be one or the other. There's no other option, right? Does n equal 50? If yes, then we got to do one thing, and if yes, we have to do one thing, and if no, we have to do another thing, including a loop. So our decision-making structure, we're going to use an if and an else. All right? So when you see these little boxes, okay, we've got to do some logic in there, and you can see these boxes here are the things we use for logic. So we're going to use the equals, and it's actually set up for us perfectly, 50. Okay, so the question we're asking is, does n equal 50? So if, and we just drag this up there, if n equals 50, what do we want to do? The else is if it doesn't. So this is the yes, and this is the no. So if n equals 50, what we want to do is, that's the yes version, we're going to print it and we're going to end the program. Printing meaning just, Scratch is going to tell us what the final sum is. So I'm just going to quick copy this block and paste it here, and anytime you drag something out, it just goes away. So if n equals 50, what I'm going to do is I'm going to have Scratch say the sum for 5 seconds. So that's going to be the final answer because the program will be done. If n doesn't equal 50, and we know it's not going to equal 50 until it runs 50 times, what do we want to do? We want to do something else. And the something else we want to do is these two pieces again. All right? So I'm going to duplicate up from there, and I'm going to get rid of the junk I don't need. Okay? So now, if n does not equal 50, then it goes down to the else. And what we're going to do is we're going to add 1 to n, and we're going to add n to our sum. Just going to make sure sum's rolling. Sum plus n. Yeah, so we're going to add 1 to our sum, and then, because it's an else, we need this somehow to loop back up and check again. All right? So I'm just going to pull this aside for a second because I know I need a loop on the no option, on the else option. So if I go back up into control, these are the loops, repeat and forever. So, or repeat until. Okay? So we know that at the bottom of this, we need to loop up top again. Okay? We need to loop up top again. And we also want it to stop after it says sum for 5 seconds, because we know on this part of the program, we're done, right? So we have to end everything after that. So we're going to go down to and grab stop all, and you notice how these things kind of adjust when you drag stuff in. So after Scratch says the sum for 5 seconds, we're going to stop all, which means it's just going to stop the entire program because we don't need to loop anymore, right? So how are we going to loop this so that it keeps checking this until n equals 50? Well, we could do it many ways. I'm going to grab a simple block that says forever, it's going to loop forever. And the reason I can put that forever in there, even though I know it's not going to loop forever, is because if it loops enough times for n to equal 50, eventually it's going to hit this. It's going to say the final sum, and then it's going to stop. So at that point, it doesn't run the loop anymore. Okay, we could have used a loop where we program it in, and maybe we take this chunk of logic out right here and say, let's loop until n equals 50. Like I said, there's a bunch of different ways to do this. But I'm just going to use this little forever block, and then I'm going to use the logic here, if n equals 50, to tell the program whether to stop or not. So let's just see what we got so far. Let's see what Scratch the Cat does. Variables, I should note this, are persistent in Scratch, which means if you don't reset them to 0 every time you run your program, it kind of remembers what you had from the last program, so it's going to keep going. That's why we always set our sum and our n to 0 when we start the program, just to clear those out and get them fresh again. So let's see what Scratch does now and if we have to make any adjustments. So there's our sum, and there's the final answer, okay? Now, he started saying our 1 for n and 1 for sum, but then he didn't say it anymore and he went right to the answer, right? So the reason he did that is because, the reason he did that, just gonna get this out of the way here, is because I only told him to say what n and the sum is outside of the loop. If I want him to say what n and sum is every time it loops through, I have to make sure I include these on the else as well, because if we're not at 50 so far for n, when we get down here, we're changing the values for n and sum, but we didn't have anything in here that told Scratch the Cat to, okay, you got to update us, you got to tell us what it is. So now that I've put these in here, he should update us. I might have to change the time so that it doesn't take forever, but now let's try it again. Instead of jumping straight from the first time through the loop to the very end answer, now we're going to tell us and constantly keep updated as to what the sum is. So there's n is 2, sum is 3. And yeah, there we go. 6th time, 7th time, 8th time, 9th time. So, 8, 9, 10, 11. That's how many times it's going through the loop, because that's what our n value is. So we're only at 12 so far. This is going to take forever, so I don't want to do it that way. I'm just going to put in, say, n for 0.5 seconds, so that it'll run twice as quickly, okay? So now there's the first time through, second time, third, fourth, 5th, 6th, 7th. Still taking a while. We got to wait till he counts to 50, and hopefully at the end he just gives us an answer. Oh, do I really want to wait 40 more seconds? Yeah, I guess we'll do it. All right, I'm going to grab a coffee here. I'll have a little sip. Come on, Scratchy, hurry up. Oh, he's motoring now. Getting close. All right, there he goes. Finally, he says, this is your final answer, 1275. I actually didn't do the math on this outside of Scratch, so I hope that's the right answer. But given that he was telling us this is loop 1, or this is n equals 1, and our sum is 1. Okay, this is n equals 2, our sum is 3. The whole way up, I think he probably did it properly. So there's just a quick little introduction to Scratch. Hopefully I didn't go too quickly on the looping and decision-making stuff, because looping is probably the part that students have the most trouble with, just trying to figure out how many times does this need to run and what does it need to do when it's looping. But we used a flowchart to help us build the program, and it helped us build the program probably much quicker than we would have been able to do it if we didn't have a flowchart and we were just kind of doing trial and error. So this was a pretty simple program. For very simple programs, obviously you don't need a flowchart, but once your programs start getting more complex and you need more and more decision-making structures, it makes a lot of sense to do a little flowchart, even to just, kind of sketch it down on a piece of paper next to the computer while you're doing it. I find it helps a lot. So hopefully that'll kind of get you started on Scratch, and also hopefully illuminate maybe the purpose of flowcharts and how we use them a little bit more. I'll be posting more videos. With regard to handing assignments in, we want everything handed in, or I want everything handed in through the website, just so nothing gets lost in email or whatnot. So the website's really good at tracking things. You can submit any type of file. If you're submitting multiple files for a program for whatever reason, try to zip them up, or some sort of compression software so you can just hand in one folder instead of a bunch of separate files. Excuse me. But for the most part, our programs are going to be one file anyway. So that's great. Okay. Good luck, and let me know if you have any problems.